Are these men guilty? Is it fair to accuse this girl? Have these women done anything wrong? Yes, says the United Nations Climate Panel. Man's use of fossil fuels is jeopardizing the future. So the United Nations Intergovernmental Panel on Climate Change, or IPCC for short, has put man on trial. The evidence consists of computer models showing that as this century proceeds, emissions of carbon dioxide and other greenhouse gases into the atmosphere will lead to disastrous global warming. But a number of internationally acclaimed climatologists say it is far too early to put mankind on trial.
6 degrees C, and now we're taking them in here.
It is not a particularly warm period we're in. Not in the context of, or in the perspective of past climates.
Interesting diagram. One of the things about the climate change issue that is a great concern to me is the fact that some of these policy decisions could cost quite a lot and yet have no effect at all on the climate.
In my commission, I can hardly find anyone which would subscribe to the IPCC scenario.
The question is why flawed models are used as a basis for enormously expensive policy decisions, far-reaching policy decisions. They shouldn't be.
I have to speak out and say that the science we have is still incomplete. And the science we're being told by the IPCC is really incorrect science.
The IPCC says that unless we reduce the rate of greenhouse gas emissions, the greenhouse effect will intensify and warm up our planet. Glaciers and polar ice caps will begin to melt. Rivers will burst their banks and sea levels will rise. The deserts will expand. If this United Nations Climate Panel scenario is correct, it will have wide-ranging consequences for people everywhere. But not all climatologists agree with these forecasts. Among those who don't is Dr. David Legates, who thinks more cautious forecasts have trouble making themselves heard.
Somehow the IPCC has become a global warming Bible, if you will. You can't disagree with this global warming statement. And if you do, you're some sort of skeptic. They question your motives, they attack you personally, and so forth.
Kyoto, Japan, 1997. Scientists and political leaders from all over the world met to debate the causes of global warming.
Excellencies, honored guests, distinguished delegates, ladies and gentlemen, welcome to Kyoto, to the United Nations Framework Convention on Climate Change.
The Kyoto meeting concluded that we must limit CO2 emissions to prevent disaster. The IPCC based its conclusions on computer models that attempt to predict what will happen if we double CO2 emissions. The worst-case scenario shows increases of up to 5.8 degrees centigrade. If this happens, and temperatures run riot, mankind will be in serious trouble. But are the temperatures we're experiencing really so unusual? Glaciologist Jørn Peter Steffensen knows a bit about that. He's looking for clues about the climate in the past in ice core samples from Greenland.
This ice is from the Viking Age, around the year 1000, also called the medieval warm period. We believe that in Greenland, the medieval warm period was about 1.5 degrees warmer on average than today.
The Inland Ice Sheet, Greenland, summer 2003. Nordgrip, the Greenland Ice Core project, is being reopened to drill the last few meters through the ice sheet to the rock beneath the research station. The ice core, over 3 kilometers in length, has been hauled up to the surface piece by piece and contains important data on the history of the climate of the Earth. It bears the fingerprints of climatic conditions over more than 120,000 years.
When we remove or drill the ice core, we leave a hole, and we insert a thermometer in the hole. We are able to map out the temperature through the 3-kilometer ice sheet. Now that temperature, if we do it precisely enough, a thousandth of a degree accuracy, then the ice has not forgotten how cold or warm it was on the surface at the time the snow fell. So, using those temperatures, we have been able to reconstruct the temperatures of the last 10,000 years.
The temperature data from the ice sheet reveal long periods with much higher temperatures than those we experience today. They tell a fascinating tale of natural temperature fluctuations in the northern hemisphere, from times when man had no influence on the climate whatsoever.
Now, as we approach our time, we can see that in the period between 4,000 years ago and back to the period 2,000 years ago, which is actually the Roman age, the temperatures have been decreasing in Greenland by 2.5 degrees. Then the temperatures increased gradually up to a maximum point around the medieval warm period, we call it 1,000 years ago. And then temperatures declined and goes down to a minimum around 1650 AD, comes back up a little in the 18th century, and then around 1875 we have the lowest point in the last 8,000 years, right here, and that matches exactly the time when meteorological observations started.
Other core samples from elsewhere in Greenland confirm that the Little Ice Age ended about 140 years ago, at the coldest point in the last 10,000 years. The natural, pronounced alteration of warm and cold periods back in time has also been confirmed elsewhere in the Northern Hemisphere. Carbon-14 dating of organic matter from peat bogs and tree rings confirms the pattern. So do data from stalactite caves in China and measurements from North Africa. There is considerable evidence that major fluctuations in climate are normal, and that the recent warming may be a natural consequence of our leaving the Little Ice Age in 1875.
The problem is that and I agree completely that we have had a global temperature increase in the 20th century. Yes, but an increase from what? Probably an increase from the lowest point we've had for the last 10,000 years. And this means that it will be very hard indeed to prove whether the increase of temperature in the 20th century was man-made or it's a natural variation. That will be very hard because we made ourselves an extremely poor experiment. We started to observe meteorology at the coldest spot in the last 10,000 years.
A warm period towards the early portion of the record.
Our general perception of the climate in the last 1,000 years is that it was warmer in the Middle Ages than it is today, and that we emerged from the Little Ice Age about 140 years ago. But now the IPCC has mooted a new climate history graph. In it, the medieval warm period and the Little Ice Age have both vanished. The graph has been dubbed the hockey stick because only the lower end of the line points almost vertically upward, thus implying that the recent warming is unusual.
During the 19th century, so in fact,
the principal author of this new graph is Dr. Michael Mann. He says the graph is based on computer simulations of the temperature series of the last 140 years compared to old tree ring data.
How likely is it that there was a year as warm as 1998 or a decade as warm as the 1990s in the past 1,000 years, given this reconstruction. And it turns out that when you ask that question, the answer that you get is that it's 95% to 99% likely. That essentially underlies the conclusion of the IPCC that the 1990s and 1998 were very likely the warmest decade and the warmest year in the past 1,000 years.
The official view coming from the IPCC is that the man hockey stick curve represents the temperature over the last 1,000 years. The problem with that is that one of the authors on that chapter is Michael Mann himself. It makes you believe that in particular that the climate view is held by many. In fact, it's really held by few.
Michael Mann's hockey stick graph is unusual, and scientists not attached to the United Nations Climate Panel have found it hard to swallow. They include Sally Balunas and her colleague Willie Soon from Harvard.
If you look at the hockey stick, the strong rise in the 20th century is meant to say that the 20th century is unusually warm, and because that's the period where carbon dioxide has been put in the air, especially in the late part of the 20th century, that therefore the warming of the 20th century is unnatural. In other words, man-made.
Dr. Sally Balunas is staff astrophysicist at the Harvard-Smithsonian Astrophysical Observatory and regarded as one of America's preeminent women scientists. Her colleague, Dr. Willie Soon, is an expert on the climatic history of the past and on computer modelling. The two find it hard to reconcile themselves to Dr. Michael Mann's sudden abolition of the medieval warm period and the Little Ice Age.
Say, Willie?
Okay. You coming here?
Yeah. Where's that linsen paper on the Hadley cell circulation?
Let me go and get it for you.
Soon and Balunas say that the hockey stick graph is an inaccurate picture of the climate because it presents the 20th century as the warmest period on Earth in modern times.
Yeah.
Sally Balunas and Willie Soon have sifted through enormous quantities of scientific articles, providing indications of the climate in the past from various regions across the world.
Oh, this is about under minimum, so let me go and put this.
The most pressing question was to see whether the medieval warm period and the Little Ice Age were global phenomena.
Now, how do you uncover past climate? We have to rely on signatures of climate, fingerprints called proxies. That is something in the environment that's sensing what the past temperature or rainfall was like. You can look at bogs, for example, and find information that says in the past it was warmer in some regions because there are particular insects or pollen there that doesn't appear during cold times. You can look at ice cores and make a chemical measurement that relates to what the temperature was going back in the past. You can look at tree growth or coral growth. There's information there. So like forensic detectives, these proxy experts can go in and look and reconstruct the past climate for that area.
See this one? I'll show you one.
Oh, yeah. Well, he agrees with us. He's in total agreement with us, isn't he? Our work, I think, has only re-verified what many of the proxy workers had done. We, after all, didn't do new proxy work. We just accumulated as much as we could. And most of the papers we took came after the latest United Nations report with the hockey stick in it.
Their calibration actually is not that good, actually.
Okay.
With the 3-ring index.
It's so hard.
No, here's another trick here. You look at this one. This one is unbelievable. No one wants to catch this.
So we asked, when a researcher had a record of past environment change, was there in that record a change that was very significant, very extreme, from 800 to 1300 AD during the medieval warm period? And then did the opposite extreme occur during the Little Ice Age? And then we asked a third question, was the 20th century the most extreme in that record that those expert researchers had developed?
This is why this curve kind of looked like a flat.
When we added up all the information from across the globe, from the Arctic to Antarctica, on every continent, we found that, yes, there was a medieval warm period, warmer than today. Yes, there was a Little Ice Age that was extremely severe and cold, and the 20th century was not unusual.
The Earth's atmosphere is the cause of all life on the planet. Without this thin membrane separating us from the cold darkness of space, life on Earth as we know it would be impossible. The greenhouse gases like water vapour, clouds and CO2 retain the heat radiation beamed down to us by the sun. Without these gases, the sun's rays would merely be reflected into space, and the globe would be cold and uninhabitable. The phenomenon we benefit from is known as the natural greenhouse effect.
The sun delivers the main amount of energy to the climate of the Earth. And the atmosphere of the Earth has a greenhouse effect in it, a natural greenhouse effect, that keeps the Earth a bit warmer than it would be if these gases weren't there. The foremost of them is water vapor. Water vapor is the most important of the greenhouse gases. Second in line is the effect of water in clouds, water droplets and water dry ice crystals. So the natural greenhouse effect has made the Earth warmer and much more pleasant for life on it.
According to the human greenhouse effect theory, the natural greenhouse effect is amplified because the CO2 we emit makes the heat blanket around the globe thicker, and hence it retains more heat, resulting in increased temperatures.
Now, because carbon dioxide is a greenhouse gas, there is concern, and it's quite correct to be concerned, about whether or not that will enhance the natural greenhouse effect on the Earth, and will it then cause catastrophic climate change to the Earth. It's very difficult to figure that out by looking at climate simulations, computer simulations done of climate, because they are so complex, and right now the science is in its infancy. But you can ask what has been happening to climate as carbon dioxide has been building up in the air, and then give an expectation for the future. The 20th century shows a pattern of warming early in the century that can't be related to the increase of greenhouse gases in the air. So up until about 1940, it's warming, unrelated to carbon dioxide. Then there's a cooling or a flattening of the temperature. That can't be you can't be getting a cooling from increasing carbon dioxide. And then there's the warming at the end of the 20th century. Now, since most of the greenhouse gases from human actions have been put in the air in the latter part of the 20th century, we really can divide the century in half and look at the first half and say those changes must be natural. So you can't look at the 20th century directly and say all the warming of the 20th century must be from greenhouse gases. Only the warming at the last part of the 20th century might be from greenhouse gases.
The message from the first climate conference in Rio in 1991 was loud and clear. Man is responsible for the global warming of the last 100 years. Today, it is generally recognized that most of that warming is due to natural climatic change, and indeed, the United Nations Climate Panel has modified its original statements. In its latest report, published in 2001, it says that only the warming of the last 30 years is due to human activity. But even this claim is disputed by one of the leading atmospheric physicists, Professor John Christie of the University of Alabama, Huntsville. He doesn't think that CO2 has the disastrous effect on the climate predicted by the computer models. He says something is going on in the atmosphere that we do not yet understand.
The natural world has a great capacity to relinquish the heat that carbon dioxide wants to trap, but is unable to because of so many processes in the natural world that allow the heat to escape. And so the world has many ways in which it tries to keep a balance, and has many avenues to do that with. And one of them is to let the heat escape more rapidly to space and not build up in the atmosphere.
John Christie says the increased quantities of CO2 in the atmosphere may not intensify the greenhouse effect because, with the help of satellites, he has made an important discovery. He and a colleague have examined the increases in temperature on the Earth's surface over the last 25 years and compared them to satellite measurements of the temperature on the lowest part of the atmosphere, the troposphere.
In 1988, when a dramatic statement was made about global warming based upon surface thermometers, My colleague Roy Spencer and I thought there had to be a better way because the surface thermometer network was not really global and had a lot of problems. So we used weather satellites. Well, we brought together the results of 7 or 8 different satellites that were launched at different times and strung together a complete time series of what the Earth was doing. No one had done that to that point. Once all of these satellites were strung together, we could then look at the temperature change over time. And the strange thing we found was that there's very little change in the global temperature. And this was a surprise to us because the surface temperature showed an increase, but this bulk of the atmosphere, the real climate system, was not. And that then caused us to realize that the human effects of climate are likely not happening the way we think they are. And that then allows us to question what climate models are telling us about the world.
Long before satellite measurements of atmospheric temperature began, balloons were used for this purpose.
Now where exactly do you want me to launch from?
They carried thermometers into the atmosphere that could return data to the surface by radio. This method has been in use for 50 years.
Okay.
When Christie compared data from the satellites and balloons, he discovered that both methods returned the same results quite independently of one another. In the last 25 years, the lowest layer of the atmosphere has hardly become warmer at all.
Nice job.
And these two very different and independent systems are telling the same story. And that story is the mass of the atmosphere is warming at a fairly slow rate. It is not catastrophic, it is not dramatic, and it does not reflect what we find in the projections of climate models.
John Christie's results caused astonishment and confusion. They show that the expected increase in global warming has not begun. Meanwhile, his conclusions pose another question too. How reliable are surface temperature measurements? Atlanta, Georgia, a rapidly expanding city of the kind familiar almost anywhere in the modern world. Nature is slowly being forced onto the retreat. Forests have been felled to make way for residential areas and shopping malls. Fields replaced by office blocks in stone and concrete. And the space between the buildings has been paved over to become motorways and parking lots. The switch from countryside to city has changed the local climate. Modern man sweats from the urban heat island effect.
If you go to a city like Atlanta or Washington, D.C., you can find temperatures 5-6 degrees C and even more in the city center versus the surrounding countryside. And everyone knows this is because of the concrete and the asphalt and so on. Unfortunately, that's going to have an effect on whatever thermometers are nearby. And that then gives you a false impression of what's happening in the long term of climate. Now, it is true that the climate of those cities has warmed, but not because of greenhouse gases increasing, but because of the change in the surroundings and the building of structures.
We humans are changing global climate. Concentrations of greenhouse gases in the atmosphere are at their highest levels in more than 200,000 years. If the trend does not change, scientists expect the seas to rise 2 feet or more over the next century. Island chains such as the Maldives will disappear from the map unless we reverse the predictions. Thank you very much.
The critics we've met question whether the global temperature is man-made or dangerous. They thereby question whether sea levels will rise as well. But if the United Nations Climate Panel predictions are correct, vast areas will be inundated. The low-lying Pacific Islands, populous countries like Bangladesh, and in particular the Maldives in the Indian Ocean, are doomed to extinction to catastrophic effect in terms of lives. Professor Niels Axel Mørner of Stockholm University is on his way to the Maldives to conclude many years of studying sea levels around the archipelago. He is the president of an international commission on sea level changes and coastal evolution, and he and his team made a discovery shedding new light on the future of the Maldives.
I have something which sheds a completely new light on the future of sea level changes. It's a wonderful piece of evidence. It's really a skeleton which has been in Sweden for analysis, and it tells a very important secret which we will decode here in the Maldives. I became very interested in the Maldives for one simple reason, because here you can study sea level changes and the various factors which interacts to change sea level in a way which you can do in no other place on the globe. The IPCC report had a chapter on sea level changes. In their writing, they say that low-lying areas like the Maldives, specifying the Maldives, will be subjected to a future flooding, and they will disappear from the surface of the earth within 50 years or at the most 100 years. These were, so to say, the baggage I came with. And then we began our research, not knowing what I would going to find. The first thing I found was a tree in the Viligili. And then I heard from the people that this tree had been staying there in the same position for at least 50 years. This is quite a remarkable tree, because it has been in this terrible situation right out on the beach, and any little change in sea level would have wiped it out. And with this position right on the beach, totally, any minute, so to say, it could fall over a big wave, and it hasn't done that for 50 years. That tells us a very important fact. Sea level cannot be in the rising mode. It can be stable or it could be a falling mode, but certainly not in the rising mode, because then it would have wiped out that. And that is the message of the tree.
Niels Axel Mørner is on his way to the tiny island of Los Fushi with Musa Manik of EcoCare in the Maldives. They're carrying a piece of the skull of a skeleton that appeared from the coral reef there a few years ago. On the evidence of where the skeleton was found, and from carbon-14 dating, the sea level at the time the woman lived may now be reliably ascertained.
Now we are coming out on this beach rock, a beach cemented into a hard rock. And outside there we see rock sticking out, and that's the place where you found
the woman. Yes.
The woman.
What actually happened to us was that somewhere along the line, a few years back, we heard that there was a skeleton embedded in the shelf. So we came and asked the people there. Then a lot of elderly people had said that it had been there for a long time. Yeah. So we thought we would perhaps go and see that. And then we wrote the article, and you got the article.
Precisely. We go around and see. That's a good idea.
Go that way, and then
that's a good idea. The reef woman was embedded in a beach sand at about same sea level as today's sea level. And that was 1,200 years ago. That's the ribs, yeah. And here is the skull. So this one should have come here, I think. That's right. And because she has a very delicate cranium, we can be sure that it's a woman. So you were completely correct. Because of its position in the reef, we can see that she lies embedded in the shore sand. And that shore sand is then covered by a cemented coral rubble, which tells us other things, that subsequently to that level, 1,200 years ago, sea level rose, brought this rubble together and cemented it, then fell back in a couple of steps. And those steps are quite remarkable. In the last 200 years, sea level has been about 30 centimeters higher than today. At about 1970, something remarkable happened. Sea level fell down to its present position. That fall in sea level, which no one had expected to see, we can see all over the Maldives. It's very well recorded and established. And that, of course, gives us a completely different story than it's generally given. Here we are at the top of the present-day wave action. They deposit these coral fragments, and they are white because they are rounded by the waves of today. The other level, the gray level, it's the top of the waves at the previous time. So that means a difference in height means evidence, real evidence that sea level has gone down. It has not gone up.
So the sea level around the Maldives is not rising. On the contrary, there has been a remarkable fall of 20 to 30 centimetres in the last 30 years. The conclusion of Nicholas Murner's observations may be that archipelagos like the Maldives will not be inundated after all.
I think the reason for this fall in sea level about 1970-75 is a strongly increased evaporation. The Indian Ocean is very warm, and the evaporation is exceptionally strong. And that strong evaporation has made the sea level in this region to be exceptionally low. So it's 30-40 centimeters lower than gravity tells it that it should be. And that's quite remarkable. I mean, it's going up so much water vapor that it has not time to fill. Those things were, for me, exceptionally interesting variables to study.
Evaporation from the oceans may actually ward off any future rises in sea level. Evaporation from the tropical oceans to the atmosphere moves the enormous volumes of water to other locations like the poles, where it falls as snow.
A rise in evaporation is a course of becoming that it becomes warmer somewhere. That's interesting. And it means if it gets more evaporation here over the Indian Ocean, somewhere else it can get more precipitation. But you cannot have increased precipitation somewhere if you don't have increased evaporation somewhere else. And that is the balance of the globe.
If Greenland and Antarctica melted tomorrow, simple arithmetic tells us that the sea levels globally then would increase by about 100 meters, which is a lot, but that's simply a matter of the amount of ice that's been built up. But it will not do that over over 1 year. It will take about 2,000 to 3,000 years for it to do so. So it's a slow process. But then if we go to the question of the biggest piece of ice in the world, East Antarctica, which equivalates something like 80 meters of sea level rise, will this melt in the future? The answer is definitely no. The average temperature in East Antarctica is so much below zero that even if we got a greenhouse effect, say, an enhanced greenhouse effect that would equivalent 10 degrees change on average, it would not melt the East Antarctic ice sheet because it's so cold. What it would do instead would make the ice grow. And it would make the ice grow simply because when the Earth gets that much warmer, there'll be so much more humidity in the atmosphere, and that will increase the snowfall in Antarctica significantly. So therefore, it sounds like a contradiction, but if we get a warmer climate, East Antarctica will grow.
The warmth of the tropical ocean generates enormous amounts of water vapor, which is distributed to the rest of the world and falls as rain or snow. So water vapor, clouds, and precipitation play a decisive role in the climate throughout the atmosphere. The United Nations Climate Panel bases its scenarios on what will happen if we double the amount of carbon dioxide in the atmosphere. This would not only result in a climatic disaster. The calculations say that more carbon dioxide would also increase the amount of water in the atmosphere. It is this cocktail, more carbon dioxide and water, that according to the theory must lead to a greenhouse effect many times as great as carbon dioxide on its own. The trouble is, temperature increases in the atmosphere just don't seem to have happened to the degree that the models predict.
A computer model is a very sophisticated computer program that attempts to simulate all of the processes associated with the atmosphere. In particular, therefore, what we need to have is as much data as possible to be able to fire the model, to be able to understand the processes. Generally, what we find is that many of the processes that work in the climate work at a variety of scales that a computer model simply cannot resolve. One of the things we do not do well in climate models is simulate precipitation. And again, precipitation is affected by virtually every component of the climate system, and in turn, every other component of the climate system affects precipitation. So precipitation is a very good diagnostic as to how well the climate model is doing. And most climate models don't do precipitation well at all. Hi, Dan.
Hey, Dave. How are you doing?
Okay.
Good.
Got this I want to show you.
Oh, okay. Let's take a
Our
look.
environmental network. A computer does only what it's programmed. And in particular, it is important, therefore, to program it correctly. The problem is we don't have perfect knowledge of how the Earth system operates. So therefore, we're working with an incomplete understanding base to try to put together what we know to see if it, in fact, generates the correct conditions.
All right, good.
Thank you.
Yep, see you later.
There's an old computer phrase that says garbage in, garbage out. And it's very important that we not only have data to drive the model, but that we also have an understanding of the processes that the model needs to simulate. As a result, if the climate model cannot simulate the current climate well enough, then we have a condition where we're trying to simulate the climate with a model that is imperfect.
Climate models can be thought of as a list of rules. And so this climate model, when it tries to predict the future, just follows specific rules. The real world is a physical system. It follows rules, but there are so many that are not contained in climate models that I think the climate models are too limited in being able to express what really happens in the real world. And so to use them for a long-term projection, I think, is not wise at this point.
Computer simulations are the tool that's used to make forecasts of temperature into the future. And the latest forecasts have a huge range. They range from just over 1 degree centigrade to, my goodness, almost 6 degrees centigrade for the next 100 years. That large range immediately tells you that the models don't agree with each other and they're very uncertain.
The Intergovernmental Panel on Climate Change and treaties such as the Kyoto Protocol are primarily based on climate model forecasts of what's going to happen in the future. Our issue associated with that then is if the climate models are somehow biased or incomplete, then our forecast of what the future might look like is too biased and incomplete.
Why that then turns into something that means there has to be action now, that's confusing to me. I can only imagine that something like the precautionary principle has been adopted as de facto policy.
The science in this case is indicating from incomplete models that we need to make political assertions and political changes. But part of the problem is that with incomplete science, we can make mistakes in policy that can have serious ramifications in the future.
When one talks about climate models and observations, I'm reminded of a climate scientist one time who said, "My model is right, it's the real world that's wrong." And I think that's what we've seen on many cases. And so using observations is not as exotic, it is not as dramatic in many cases, and occupies sort of a lower level in the climate hierarchy of who gets attention. Because climate modeling enterprises are very expensive, so they have these constituencies built up that seek to maintain their work. Observationalists generally do not have that same attention. And so developing observational data sets is sort of the weak sister in the climate community. Yet climate observations are supposed to represent the truth, not the theory, against which our theory is to be checked. I believe observations, and that this is where our basis for climate change should be understood and the perspective from which we should see the future. When you look at the past, I don't think the perspective of the future is all that bad. A finding such as ours that says the satellites show no real serious global warming is not well received in much of the climate community, and I recognize that. But it has never been a goal of mine to be part of the mainstream of the climate community. My goal has been to provide scientists and the world with the most accurate data possible that we can judge and understand what the planet is doing. And so the data and the results are often greeted with skepticism because so many people have a belief that global warming is going to be a disastrous thing and that it is occurring right now to a large extent, that this picture doesn't fit their picture of the world. And as a result, I've had a very interesting life dealing with controversies and so on.